I mean, we can set up that, right? I'll ask Stan to buy some mangoes too, okay? Okay, so let's start with the day 2 agenda is here. So I haven't finished my charts for day 2. There's already about 80 charts. It's going to be for 2.5 hours, 3 hours tomorrow, 10 to some number of hours tomorrow, okay? You guys can see that, but I'm going to take you through this journey, okay? How many of you heard about Bitcoins? I want some audience. How many of you think Bitcoins and blockchain are the same? Guys, it's the same, okay? Let me tell you, there is no difference between Bitcoins and blockchain, even though people say Bitcoin is different than blockchain. So let's think through blockchain. The original paper by Satoshi essentially had a concept of a blockchain that he actually used to essentially build a distributed network for exchanging money, okay? Keep that in mind, but let me take you through this journey of what blockchain is. So in the classical internet, as you can see, where we used to exchange information and content and services. And so if you think about Google, Google is one place where we pretty much rely on Google for everything, right, in terms of searches and things like that, right? So, but internet has come a long way from being purely a content delivery or even service delivery to become a commerce for people to do business over the internet. And that's right, which is as things like web application and other infrastructure have been built on top of the internet. So internet started off with TCP/IP and then moved up the stack of TCP/IP. Yes?
Sir, is your label mic on? Is your mic on?
There's no mic.
There's no, oh, I see, because of the
So,
we'll shut the window.
okay. 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 Is the podium mic working? I can stand here and talk.
If I can help you. Why don't you go ahead and I'll see if I can get this going.
I'll try to shout even more. Okay, I'm not used to yelling at people. So today I'm going to yell at you guys. Okay, and I try to be much closer to you guys. So, as you know, internet has come a long way, right, since the TCP/IP days. So what is blockchain? In blockchain, it goes a step further. Think in terms of two things: values that are exchanged and trust that you actually build. How do I create value on blockchain? Value doesn't mean money, it means more than money, okay? And then there is a concept of trust that you have to build on top of that. So the two things that actually brings to table, especially when Satoshi network, I use the word Satoshi network for Bitcoin because that was the original network that was put together, made the value system mainstream. Essentially, what does that mean? Internet, if you look at from a banking point of view, they essentially have a centralized control. What Satoshi did, he said, how can I make a centralized banking system into a decentralized banking system? So how many of you guys have read the original paper of Satoshi? Okay, how many of you think what was the underlying fundamental principle that he brought out other than, making money and then, things like that? From a technology point of view, what did the main problem he actually solved in the Bitcoin world that you couldn't solve it previously? Any guesses? Yes?
Decentralized currency.
You could do decentralized currency before, but there is one problem that he fundamentally solved that could not, if we couldn't solve that, we couldn't get Bitcoins. Anybody? Huh?
Anonymity?
No.
To avoid the double spending problem.
No.
Developing a transaction history that's tamper-proof.
No. Okay, let me tell you. Fundamentally, he solved something called Sybil attack. How many of you guys know about Sybil attacks? Sybil, Sybill. That's the fundamental problem he solved in Bitcoin world. Let me explain that. I'm giving a talk at IBM, about this. If anybody wants to come to IBM, I forgot, November 1st, please come back. Come and you could come there, right? So I'm actually talking about the comparison between Bitcoin and that. Let me tell you what Sybil attack means. Suppose you have a decentralized system. Let's take voting as an example. How do I spoof the voting system? I can create as many identities as possible. Sybil attacks is essentially some, criminal guy will create as many identities as he can. How did he prevent that identity that could be created for free? He essentially created what is called proof of work. If you want to create these miners, you cannot be, any arbitrary guys cannot be a miner. He needs to expend some money. And that's the fundamental problem which he actually solved in the Bitcoin world, so we can actually have a decentralized system. Everything else comes together, right? And I'm not going to go into the Sybil attack mode, but you have to keep that in mind. Because of that proof of work, he was able to prevent any arbitrary person to come and mine and build the trust model because he has the way of creating for free as many identities as possible. Now they cannot because they have to actually expend computing resources to do that. So let's take a step back and understand blockchain from two things. It's both a technology and a platform for distributed computing, and it's also a commerce or a business where trust and values are exchanged among parties or identities, okay? So that's essentially are the two basic concepts. When you think about blockchain, a lot of us think only in terms of Bitcoins. We don't think in terms of technology, we don't think in terms of business, but they come together, and Bitcoin was the first, Satoshi was the first person to essentially solve this fundamental problem of distributed system in a scalable way so that you can actually do decentralized computation much better. So distributed computing has been there for 25, 30 years. One of the first papers I read was Leslie Lampert's paper back in 1989, 90, right? And at that time, that paper has been there. Fundamentally, nothing has changed in distributed system until up to the point when Satoshi came up with this paper, right? After that, everybody got excited. Both the crypto people and the distributed computing people got very excited about this. And that's why you see there is a lot of excitement around Bitcoins, okay? So let's go with a very simple use case in mind. This is all about mangoes, okay? I love mangoes, and I love mangoes in various forms. You can think about Alice wants to have a mango party, okay? She wants to get the best mangoes for her party. So she essentially first goes to an online store called Everything Mangoes, browses the store just as we do in Amazon, and figures out, hey, this is the mango that I want to buy. But there is something missing there. How do I know where that mango was grown? Who actually fertilized that? Which country it actually origin? Is there any food poison associated with that? Some of those things is essentially what blockchain actually brings to the story, right? So the fundamental thing that blockchain will bring here is the fact that we are going to put every life cycle or all the life cycle of the mango from the tree to your plate. The plate could be slices of your mango. It could be a pickle, Indian pickle, one of my favorite one. Mango smoothies, one of my favorite for my daughter, right? And that's essentially what we want to kind of. So I'm going to use mango as an example. Think of your mango as anything that has a life cycle from creation to death or consumption, right? How do I essentially track the provenance of that life cycle so that people who look at that life cycle have trust, the confidence, and the value associated with that? Any questions so far? Yes?
For each of these inputs, you would still need to input the data, so why couldn't you use a regular database?
I'll come back to that, right? We could have a regular database. That's when the centralized banking system would look like. Your centralized banking gives you that database. We all go to Amazon for everything, right? Maybe some other store. What this provides you is the decentralized mechanism where there is not one party controlling all aspects of the life cycle of the mango, right? So you could own, if you have enough money, you could own a peer node, so-called peer node, or a node in your distributed system, and that node will essentially have a replicated copy of maybe somebody else owning that, and they all will have the same replicated copy. So that's when you become decentralized. Yes.
Volume of data created, would it be large, and how scalable would the solution be?
That's one of the biggest challenges of Bitcoins too, right? If you look at Bitcoin, they can sustain about 10 transactions per second. That's not good enough. A credit card has about 25,000 transactions per second. And there you get a little bit. So we need researchers, not me, I'm not in research anymore, to essentially come up with technologies to essentially scale in a massive way. Very good question. Okay? So let's look at, this is my definition of blockchain computing model. Ignore the bottom part for now because that is also an important part. I haven't put that in the definition. It can be, it need not be, okay? So there are 6 parts to blockchain, according to my definition. This is, I call it as the definition that I came up after working in this space for some time, right? You have to think in terms of sequence of transaction, first thing, right? So think about mangoes going through various states. You cannot have a mango on your plate if it is not being created on a tree. Maybe it's a different mango, but still, if you want to track a particular mango on a tree, you have to have that life cycle. Second one is there's a notion of channels, which Bitcoin, I'll come back to. Let's look at channels. Let's not compare it to Bitcoin yet. The notion of channels means mangoes is nothing to do with diamond, even though you can use diamond to pay for mangoes, but I don't think you want to do that, right? 1 diamond per mango, no. But smart contract, rules, or constraints on the states of the mango. What kind of states you can have? These constraints need not be just on the states, it could also be on the transition. When I go from one life cycle to another part of the life cycle, what are the rules that will take me from one life cycle to one state of the life cycle to the other state? Third one, or the fourth one, is consensus. Who all agreed to these rules and how did it get actually executed? Shared ledger is your standard blockchain. It cannot be tampered, so you have to make sure that you cannot tamper it. Okay? So there are things like identities and membership, and I'll come back to that. Any questions on this? Anybody have any question on this particular? Because this is extremely important for the rest of my talk to keep this particular definition in mind as we go through this journey of blockchain. Yes?
Confirm, the difference between 4 and 5 is, one is the voting on the shared ledger? So
yeah, consensus is the voting, the other one is the actual entry of that vote, the result of that vote. Okay, any other question? Okay, let's go to the next chart. Let's look at this between permissioned versus permissionless. Permissioned is, think about the following. Everybody knows about golf. There are 2 types of golf, right? Country club and public golf course. How can you go to country club? You have to be a member of that club. You have to pay a lot of money to be a country club. Permissionless is like public golf course. There is one right across my house. Anybody can go play golf there, right? You don't need to. You pay $10, you'll get a bucket of balls and you can start swinging, right? Country club is where Donald Trump goes, Genie goes, other people go because they are part of that country club, right? So other than that, let's look at this from blockchain, the definition that I just gave you. What is missing in the classical Bitcoin world is the concept of channel. They really don't have this concept of channel that is there. That means if you have a blockchain, say for example, Ethereum or Bitcoins, they pretty much use the same blockchain for both for diamond and for mangoes, right? You really want to separate them out. But I need to separate them out fundamentally at the application level, all the way down to the stack. I cannot simply separate at the application level, but when it comes to the actual blockchain itself, they are essentially put on the same blockchain. And then you can actually handle some of the scalability, right? The second one is the consensus. The consensus in the Bitcoin world, even in the Ethereum, proof of work, proof of stake, other kinds of proof of authority, all of these are typically, especially proof of work, is a probabilistic distributed consensus model. And if you want to know more about that, come to my talk in IBM. I'll explain what that actually means. The one here is, there is also a second thing. In terms of the trust, what is the truth? The longest chain is the truth, no matter what anyone says in the Bitcoin world. The longest chain is the truth. Your chain may expand, but there is a probabilistic problem associated with that. If my chain kind of goes like 6 blocks, the probability of that, preventing that gets harder and harder, right? So when you actually buy and sell things on Bitcoin, you wait for that blocks to kind of expand up to 6 blocks before you actually send the money. Otherwise, you may lose that money, right? In the Bitcoin world, there is still double spending both in the regular, with the permissioned and non-permissioned, nothing to do with double spending. This is about the consensus and the expansion of the chain itself, right? And that, if you look at this definition, there is no difference between the Bitcoin world and the blockchain world that we traditionally talk about. These are the only 2 differences. Yes, there is membership, identities, anonymity. We can all handle in both cases. But fundamentally, these are the 2. Any question on this?
Could you repeat one more in a few sentences?
Okay.
Those 2 problems.
So the first one is channels. I need to understand from an application point of view, am I actually doing commerce on mangoes or on diamond? Mangoes and diamond, they have nothing to do with each other, except some rich guy may give a diamond to buy a mango. That's a different story. But those 2 are 2 different worlds of the commerce. They never come together. They could, but they don't usually, right? The second one is essentially on the consensus side. The distributed consensus in Bitcoin is what is called probabilistic consensus model, based on 2 concepts. The longest chain, which is the truth. The other one is the mining based on proof of work. You could also think of proof of stake or any of those things, but I'm going to use proof of work as the. So those are the only 2 fundamental differences, right? And how that technology is built, it depends on these 2 basic concepts, basically, right? And IBM has taken an enterprise ledger or enterprise hyperledger, right, fabric, and that's based on you can essentially customize what kind of consensus model you can have, okay? They allow you to bring any different consensus model, okay? And, yes?
So for private blockchains, there is no proof of work to confirm?
You could have a proof of work, but now think about it. What does proof of work in a private or permission network actually mean? You have to fundamentally think you don't have the Sybil attack problem in permission network. So if you bring in proof of work there, you're wasting your time there, basically, right? Because in proof of work, at least in Bitcoin world, you probably get about 10 transactions per second, maybe 20 these days. Ethereum may be doing 20. But if you are in a permission network where you understand all of the identities properly, you can actually scale much better using a better algorithms. You could still use randomized algorithms there. But you don't want to go do proof of work there. It really doesn't make sense. But you could. Nobody's preventing you from doing it. But you don't want to do that.
That's the beauty or power of the permission ledger, actually.
There is beauty on both sides. I agree with you. But there is beauty on the both sides. It depends on how you actually see it. Yes, exactly. Okay. So let's look at this from a blockchain model that I just explained using this simple figure. This part in the part, let me go to my hand. I think that's easier because this somehow, I don't think this thing is actually, I don't know whether the thing is not working. Okay. So we have what are called peer nodes. There are various peer nodes. All those green guys, they are peer nodes. Okay. Those peer nodes, we think of them blockchain as a block where you have Bob and Alice. They are essentially doing some business together in some fashion. I'm going to use Alice Bob, classical crypto names, right? And they are submitting sequence of transaction to the block. Alice is doing the same thing. At the end of the day, those sequence of transactions get interleaved, basically, right? And both of them have to agree on that interleaving of that sequence of transaction. For instance, the sequence of transaction from Bob would be he'll be paying for mango today, tomorrow, day after tomorrow, and Alice will be sending mangoes to him as she gets the payment. And she cannot send a mango if she doesn't get the payment, and he better get his mango once he pays, right? So those are the sequence of transactions that you want to keep. So now think about Bob is submitting to his own peer node. Maybe he may not run on his own. He may have somebody else managing his peer node, right? He's going to submit that, and Alice is going to do the same thing. Those sequence of transactions are essentially submitted into the shared ledger. After it has been ordered, the Hyperledger fabric uses the word orderers. Those are nothing more than consensus nodes. Let me pause here, and I'm thinking about deterministic consensus model here, not the proof of work. Okay, let's not talk about proof of work anymore. We are done with permission versus permissionless. If we want to discuss some of those, we can discuss later, right? So think in terms of distributed consensus model that is deterministic. It could be randomized, but it'll still be deterministic. I'll come back, to randomized and things like that later, right? In that distributed consensus model, who is doing the consensus? Why do we need those consensus model? Can somebody tell me, why do I need those consensus model? Consensus is what? Is it human beings? Is it computing nodes? What are we consenting on?
Status of a blockchain, whether to commit it or
Fantastic. That consensus essentially is used to ensure the state of the blockchain is agreed upon by all the interested parties. What is the state of a blockchain? Is nothing more than sequence of transactions submitted to that. Every block has a sequence. Within a block, you have a sequence. Those consensus are essentially are used for agreeing on the state of the blockchain itself. Can you imagine you going into a meeting and having a consensus? What is the consensus you're going to have there? Very often we don't get consensus. Somebody with a big stick says, I'm the boss, we are going this way. It doesn't work here, right? The consensus model here, the kinds of failures, I'll come back to the failure model, but you understand what I'm trying to address here. The consensus model here is agreement on sequence of transactions that are submitted to the blockchain. That is fundamentally, you have to assume, think through that. When you think about consensus about human beings, we don't really have consensus. We essentially yell and scream at each other in a meeting, and somebody says, this is the thing. I'll give you a classic example. Assume that we have to put an executive chart that goes, say, for example, the CEO of the company, right? What do? We bring a bunch of leaders, ask them to come to a room and agree on what needs to go up. I'm sure there must be one or two in there who has a big stick, who says, this is what goes, right? That becomes a little bit harder, but here we are talking about where everybody have equal voting rights. You could have other models, but let's assume that everybody has same equal voting rights in terms of consensus. Okay. Now let's look at the same from a Bitcoin world. You had a question? Yes.
If in an instance where in one node would have limited internet connection, but they want to commit a transaction at X time, but it's not communicated to the rest of the blockchain until say an hour later. How is that discrepancy?
Hold that thought. Or you come to my talk, but hold that thought. I'll come back to that because I'm going to talk about failure models and things like that.
Could you give us the timing of your talk?
I will. It's on November 1st, and I'll send that email to Stan. Where is Stan? Somewhere. Okay, Stan. I'll send you your email so you can send them there. It's in Yorktown. You have to come all the way there. I came all the way from there. You can come there, right? So let's go to the Bitcoin world, right? How does Bitcoin world actually look at this model, right? It's exactly the same thing. You have a sender and a receiver, and you have a bunch of miners. These miners essentially will chase these dollars and essentially say, hey, I agree, I don't agree. And essentially they'll put that into what is called, this should be Genesis or primordial, right? There's an or Satoshi's block. I like to use the word Satoshi because I think he's the one who essentially started this, okay? So the two models are pretty much the same in the way we submit transactions to the blockchain. Two people want to come together, they interact through blockchain, okay? So blockchain is a discipline. If you want to, when I say discipline means you can offer a course, not a course, sorry, an entire master's program in blockchain. Maybe you guys should do that. There is so much in blockchain, all these technology will come together, okay? I'm an adjunct professor at Mercy College. I was one of the initial starting of the cybersecurity program in Mercy College. If you guys want to do this, I could come and help you out to chart out this.
Would you like to be adjunct?
Sure, if you pay me enough money. No, I do this as volunteer. I'm more than happy to come. I'm more than
Oh,
happy
that
to
would
come,
be wonderful.
right? So you have to understand this. My wife has an MBA, right? I read most of our MBA books, the economics and accounting and things like that, right? And that helped me a lot on the economic side, basically. Okay, let's go to this. Let's define distributed computing 101. This is all I can talk about distributed. By the way, this discipline is one of the hardest. Blockchain is made up of 3 core technology from a fundamental core. One is distributed systems, second is crypto, the third one is game theory. Okay? All 3 of them are very hot areas to comprehend. So let's look at distributed computing. Distributed computing consists of n processes, P1 to Pn, that communicate by passing messages over peer-to-peer network, right? Any peer-to-peer network, that's it, that's my distributed computing. But what are the 3 factors that make distributed computing very hard? Asynchrony, okay? I'm going to address your question. Second one is what is called limited local knowledge. There is nothing called global view. And the third one is failures. So to go back and answer your question, assume I want to participate in a consensus. I'm sitting in Singapore, right? IBM Singapore. I'm in this meeting. All of a sudden, the phone dropped and there is no internet connection. How do I essentially, all the other guys who are waiting for that person's consensus, remember this is purely based on deterministic consensus model, right? All the person who are waiting for him, is he alive? Is he dead? What happened to him? We have an assumption that he may not be dead. Thank God, right? But we know he exists. Do I wait for him? Do I wait for him? How long do I wait? If you have an asynchronous system, not synchronous system, but an asynchronous system, even a single failure, you would never get consensus. That's essentially what is the FLP theorem. It's probably one of the most seminal paper in distributed system, that's what it says. If you have a deterministic consensus model with asynchronous communication, a single failure, you will never get consensus. You have to go read that paper to really understand what is going on. Why is that actually true? Why is that impossibility result? So I gave a talk about 6 months ago at IBM, why blockchain is hard. I took 5 areas and showed how many impossibility results actually exist. And I expected 10 people to show up. 150 people showed up in research, which is rare, only if they, right? So the second one, you cannot have distributed systems without the notion of time. God created time. I mean, whether you believe in God or Big Bang or anything, Big Bang created that time. If you didn't have concept of time, you will not have distributed systems, right? If you want to understand the notion of time, you have to read the seminal paper of Leslie Lamport, which is Times, Clocks, Events, and Ordering, okay? The third one, which is no global views. No global view essentially means when I'm actually doing distributed system, the person who in Singapore has the information, what she knows, and what got communicated with some other person. When I'm interacting with the person in Singapore, those are the only 2, right? Whatever information I exchange, that's the only thing that I know. And the other one is whatever she knows in Singapore. So if you look at distributed computing, this is kind of, the world that distributed computing kind of encompasses the whole thing. Okay, any questions on this? Okay, let's look at famous distributed computing people. If you want to learn blockchain, other than talking at very high level, you have to read these guys' papers. And some of these papers are not easy to read, okay? The paper, which if I recall, Leslie Lamport, which I call him as, I hope other people don't get done. It's being recorded and shown, right? I hope other people don't come and yell and scream at me. Why am I not the father or mother, right? To me, these are the guys that I kind of cherish when I was learning about distributed system. Leslie Lamport, I call him as father because he's fundamentally changed the way we think about distributed system using that paper called Times, Clocks, and Events. He essentially introduced the concept of relativity theory to distributed systems. Yes?
May I make a comment?
Sure, go ahead.
Actually, I read the paper, and the paper actually addresses very simple topics, but
Yes.
very fundamental topics.
Yes, exactly.
And Leslie Lamport was the person who picked the cherries first.
Definitely. That's how research is, right? Who picks the cherry first? But his subsequent papers were also some of the fundamental papers, like part-time
No,
parliament.
of course.
Yes, right?
I'm not
So he actually he got a Turing Award for that, right? The second person I call mother of distributed, Nancy Lynch, I also put her on the distributed algorithms. Barbara Riskow's, which is practical Byzantine fault tolerance paper, it's not just about Byzantine fault tolerance that she actually addressed as a practical, even though it is NP hard, it's exponential, even though she calls it as practical. Actually, it may be even impossible, right, in some cases. But she did address. Some of her paper that she worked on in both programming, my PhD is in programming languages, basically. Her work in programming language and distributed system fundamentally changed the way we actually build systems. She also got Turing Award. Jim Gray used to work at IBM. He disappeared in 2007, 2008. He's called the father of transaction processing. If you want to understand transaction processing, two books you have to read. One is Phil Bernstein, the other one is Jim Gray. You have to read those two books. You have to, like a Bible, right? You won't understand it. Believe me, you won't understand it. It takes a long time to understand it, right?
I spent countless hours on reading update algorithm of
Yes.
in the distributed system,
Yes.
and I still don't understand.
The other person is Nancy Lynch. You have to read her book, Distributed. When it came out first time back in 87, 88, I was still a student. And I was trying to understand, at that time I was still a young, my brain was still working. These days my brain doesn't work. And the other person is definitely Dijkstra, right? Dijkstra is the grandsire, okay? So the other one here is some of the seminal papers. Impossibility research, which is the FLP theorem that I mentioned to you. Part-time parliament by Lamport. Incidentally, Lamport himself mentioned it took that paper 10 years to get it published, but on an ACM transaction Toplos paper, I think, or I forgot, one of those. It took them 10 years because they didn't believe it. They didn't believe it. If you go read it, there is nothing distributed system in it. He all talks about how parliament works, basically, right? Again, Barbara Riskow's, the other paper, Byzantine General Problem, is another very fundamental paper you have to read. The other paper that you must read is Linearizability by Maurice Hurley and Janet Wing, okay? You have to read that paper. The reason for that is whenever we talk about strong consistency, the only thing that you have to think about is linearizability. There are many different types of strong consistency when people talk about. In the banking system, in other places, when you talk about strong consistency, it's actually linearizability. There's something called CAP theorem, and that essentially is the linearizability of your consistency there. Okay, top 10 myths about blockchain. This is something that, I write blogs. You can go to my LinkedIn and you can see about 20 blogs there. This is one of, I don't know if I had put this as a blog, I forgot. I think I did mention somewhere. People think tamper-proof means write once. It's not. You can write as many times as you want. Why do you think we have tamper-proof in blockchain? Tell me the reason. Can anybody tell me why is it tamper-proof in blockchain? What makes it tamper-proof?
If somebody proposes an incorrect transaction based on the previous information of the ledgers, then it will be rejected.
No.
So they can't tamper.
What is the underlying technology for the tamper-proof? Why it becomes tamper-proof? What does it make it tamper-proof?
Well, you cannot rewrite the history. It is extraordinarily expensive and impossible to get consensus.
That's only true in proof of work, right? That's only true in proof of work. What about in permission ledger? But by the way, Ethereum did rewrite the entire history. They created two spin-offs. Ethereum, we have Ethereum Classic and Ethereum, right? Because of some concerns.
Multiple copies.
Exactly. There are two things, right? One is the hash code of the previous block get attached, and the other one is you have multiple copies. Those two things. In proof of work, we really don't worry too much about the multiple copies because, they could have a zillion copies there. What actually prevents there is the hash code, and for me to compute that hash code, I actually do proof of work. In the permission ledger, you have to have two things. One, the multiple copies, all of them have to agree on, right? And the second one is the hash code. Those two things actually makes it. So, but you can still have multiple writes. By the way, in both worlds, tamper-proof doesn't mean you cannot tamper it. It becomes harder to tamper. Okay. The second one is the second point. I mean, the number 9 is tamper-proof is because I'm using cryptography. No, tamper-proof has more than cryptography. You also have things what you just mentioned, replication, right? Blockchain will eliminate disagreement, so I can bring people together. Remember, blockchain is about consensus, is about agreement. Blockchain is not going to prevent any disagreement. If that's the case, the government should be using blockchain, right? The Senate should be using blockchain, right? So blockchain is useless when there are only 2 parties. You can still use blockchain when there are. So the consensus model that you think about, it's not about 2 parties. It's about failure models on a distributed system. So that's why, okay, a blockchain will eliminate third party or middleman. How many people believe that's true? Even in the Bitcoin world.
Well, that's what we are told.
That's what you're told. It will not eliminate the third party. And I'll tell you why. 2 reasons. In the banking system, why do we have banking system? One, yeah, they have centralized authority, they have a big stick. They actually manage the risk. What will happen, this has happened all the time in Bitcoin world. Who owns the risk if you lose your Bitcoins? Millions of Bitcoins. You take a big risk. This is like, right? So in the enterprise world, who's going to own the risk? So never think that Bitcoin is going to eliminate third party. Somebody has to own the risk, and that third party is owning the risk. The banking system is owning the risk. The federal government owns the risk. Okay, so blockchain is good, Bitcoin is bad. I already mentioned this. There's nothing, they both are saying to me. Okay, we cannot talk about blockchain without first talking about Bitcoin. That is bogus. We can do. Yes, sir.
So how is the shared risk of owning managed when it comes to blockchain?
Very good question. Shared risk in terms of what? In terms of failure, in terms of...
And the risk of loss.
Okay,
Because on a
so
conventional system,
suppose you have a set of peer nodes that are running, right? And they're all running the same smart contract. And assuming that there is a flaw in the smart contract, everybody who owns the peer node that runs the smart contracts owns the risk of that smart contract. So that's how you get your shared, right? Risk. So the failure model that you're talking about, it's not just about the node going down, it's also about the smart contracts that are running that you agreed on originally to run on those smart contracts. And those smart contracts are Turing complete, you will have a lot of risk if you are not careful with it. Okay? We cannot talk about, right, there is nothing new in blockchain. How many people think there is nothing new? A lot of people say, oh, there is nothing new in blockchain. It's not true. Blockchain essentially made cryptography once again, although crypto has always been mainstream, but the way we do cryptography, and second one is distributed system, and third, game theory. How many people think game theory is important in blockchain? What is the mechanism of game theory? How many people know game theory? What is the concept of game theory in blockchain? Go back to Bitcoin world.
So it's more with proof of stake models.
No.
Because a bad actor is incentivized to work for the network.
Fantastic. Incentivization. A miner wants to come and mine something is because he's incentivized to mine. And that's the game theory concept, right? So think in terms of game theory. There are some impossibility results in there too. There are certain things you cannot do, and that again goes back to FLP theorem. Many of these impossibilities in distributed system always ends up pointing to FLP theorem, okay? Blockchain will make money for me. No. You make money because you're smart, not because blockchain is going to make you smart, okay? Blockchain is better than Swiss bank. Who uses Bitcoins? Drug dealers? I'm not going anywhere. I'm not going beyond that, okay? Right? Ransomware. I bet you heard of ransomware. Somebody says, I'm going to cryptofy or hash your your database unless you pay me some money in Bitcoins. They think that the federal government doesn't know where you exist. Believe me, if you think federal government doesn't know, sorry, you're in some other world. The federal government knows everything you do, right? So There is a hype in blockchain, and it's kind of coming together there. As you can see, the blue part is somewhere in 5 to 10 years. That's about 5 to 10 years, where it will hope to become mainstream, basically. Okay. There's what I call sense and sensibility. I don't know if you heard of sense and sensibility in the classical world, right? I wrote this blog. So where do I use blockchain? So when does it make sense to use blockchain? One is transactions that cross multiple organizations or companies, where there is separation of duties. Even if it's in the same company, when there is separation of duties like financial ledgers, person who enters will not be able to do the audit of that ledger. The person who travels cannot approve his own traversal. Those things you will probably end up having. Central database does not help, because for somebody to come and access your central database, I don't think I'll be able to let any company to come to our database, right? Unless you want to put the other thing. The second thing about central database is, when you are doing business with somebody, assuming I'm doing a business with him, I put everything on the table, he puts nothing on the table. That's not a fair game. In blockchain, when you bring parties together, make sure somebody who comes to that party who wants to get involved in blockchain from a stake point of view, he better put something on the table. He cannot simply take other things. That's why central database will not help, right? So the third one, transactions are executed and monitored by multiple parties, right? Where segregation I already talked about, there are disputes, and these disputes can be resolved based on proof and evidence rather than dispute based on beating up on people, right? And third one is transactions that are recorded should not be tampered. Audit, compliance, all of these things will become important, right? And where money actually matters. You don't want to put something on a blockchain where if you can't have a business case for it. Just because blockchain is a new shiny object, a lot of people think, hey, can I do blockchain in that? At the end of the day, you have to make money. If you don't think in terms of business, and that's why I went to the business unit, to make money, right? So I'm going to spend, hopefully I'm on time, I'm going to spend some time on consistency model, consensus model. These are subjects by themselves, right? You can write a whole semester on consistency model. Let's see if I can actually do that. Okay, so crypto, there's only 3 things you need to know. So I'll go very quickly. You probably know there's a plain text, there's a ciphertext, you have an encryption, and you have a decryption. If you use the same key, it is symmetric key. If you use 2 different keys, it is public encryption. Okay, hashing, you take one of your encryption and make that into a hash. SHA-256 you can use as a hash, and you get a fingerprint, basically. Okay. Third one is digital signature. You have a hash value, a document hashing algorithm with a private key, you get a digital signature, basically, okay? That's less than 10 minutes, I'm done with that. That's all you need to know, okay? Okay, I hope you can actually read this. By the way, when I gave the talk, I usually don't like PowerPoint, but in this case, I had to use PowerPoint. I usually write all my slides on a sheet of paper and scan them, okay? So what is consistency? As I mentioned, when you have concurrent reads and writes, what is the meaning of a read and what is the meaning of a write when you have sequence of them, right? That's essentially what consistency is. So consistency model describes how and when different nodes in a distributed system sees the order of the transaction. I have a bunch of nodes. We are submitting the sequence of reads and writes. If everybody sees the same order, we have consistency. And that's essentially but that's not an easy problem to do. If you had a sequential machine, that's very easy because there's only one person doing that, right? So in terms of consistency models, the weakness, you have strict consistency, and then there is something called strong consistency, which is linearizability. There is something called sequential consistency, causal and eventual, right? So there are also things that you will understand, which is called, what I call as consistency alphabet soup. There are at least 50 different consistency models that people think that their consistency model is better than yours. Pick what makes sense for you for the application that you're building, okay? And then there is things like cap theorem. How many of you heard of cap theorem? How many of you know what is acid? Probably not, right? I'm not going in there. What is base? NoSQL. Okay, here is a little dialogue. Alice asked, Bob, are you expert in SQL? No. Are you expert in NoSQL? No. Are you expert in ACID? No. Damn it, what is your base? Then I don't know, but I'm an expert in blockchain. If you don't understand these concepts, you don't know blockchain. You have to know what is ACID. You have to know what is base and things like that, okay? So when you go read, that's why I'm asking you guys to go read basic distributed system 101, basically, right? Let's look at consistency in the following sense. There's a person in India, Alice is in India, and Bob is in New York. You don't need to, you guys can read this, what does it mean, who goes first and who goes second, right? Who's on the first base kind of a concept here. But let me explain this very naturally. Assume Alice is in India, and assume I'm Bob, my wife is Alice, okay? She makes a transaction, it goes to an ATM, does deposits and withdrawal. I'm in an ATM in New York where I make deposit and withdrawal. What is wrong with that? Where do you see consistency problem? Assume I deposit $100, she withdraws $200. Assume the base is, let's assume we start with 0, right? Does it allow in the consistency model, right? Now think about consistency from, people talk about something called eventual consistency. What does that mean, eventual means? Eventually I'm going to be consistent. And some people say, I need strong consistency. And some people say, I don't need strong consistency. In the short run, when I actually see, when I deposit and withdraw money there, that local knowledge, I need to be consistent on that local knowledge. The same thing with my wife on the other side, right? In the long run, if I actually deposit and withdraw $100, if I deposit $100 and try to withdraw and the bank says, no, you have no money, immediately you're going to call, at least if it is my wife, she's going to call the bank, hey, I just deposited $100, where did that money go, right? The same thing, if you look in the long run, I just told you about short run, right? As I'm doing the transaction, I need consistency, which is usually what is called linearizability. Imagine at the end of the month, you get a bank statement. You did a whole bunch of transaction, and if you're like my wife, she kind of puts everything in paper, right? Which is called the book ledger, in paper. And then she compares them and say, hey, where's the money? The money disappeared somewhere out of thin air. Immediately she's going to call the bank. So you need strong consistency in the long run. Somewhere between those two, you really don't need strong consistency because you don't know. If you don't know, you don't know, right? Yes.
Is this a hypothetical example, or
This is
she actually does it?
No. I hope my wife is going to yell at me now. There goes my 26 years of marriage. So
We didn't hear it.
If you have a strong immediate consistency, wouldn't that mean by default you would have?
not necessarily. Depends on failure models, right? Asynchronous models and many things. There's underlying assumptions you have to make, right? But just because you have strong immediate consistency, you know why banks are important? They do settlements at the end of the day. They take the risk. What they do is they do the adjustments. What is strong consistency? I see the same order here, my wife sees the same order there, and I guarantee those two orders are the same. You cannot guarantee that. You know why? Which is what CAP theorem tells you. There's something called partition tolerance. How do you know the network is actually existing there? You gave that example. What happens if the network goes down? You will never get strong consistency there. In CAP theorem, I wrote a blog where I say, drop consistency. Guys, don't spend too much time on consistency. Focus on availability, because if my ATM machine is not available, I cannot do anything. And focus on partition tolerance. Exactly the same. Yes?
Actually, I'm not sure though. The deposit transactions usually becomes viewable or seen the next day. They are not immediately available. It's because of this problem, I guess.
They do settlements at the end of the day.
Yes.
Right? Imagine, let me give you another simple example. Assume you transfer $10,000 from one bank to another bank. It should take, in the internet world, it should take seconds, right? Go try it out and see if you see the money on the other side. You know what the bank will say? The first, $100 you can withdraw anytime. They take the risk on that. If you want to, then next day you can withdraw up to $1,000. And then you eventually, after a week, you're allowed to see that $100,000 or $10,000 that you did. That's how the banking system works, because they take the risk. So blockchain, you guys can read this, I'm not going to go. So why consistency is hard? Way too many leaders. Imagine in your meeting room, you have 5 leaders. It says, I'm the leader. You will get into trouble. There are leaderless protocols and leader protocols. The Honey Badger, somebody said they work with Andrew Miller, right? The Honey Badger is a leaderless protocol, for instance, right? Network partition, how do you deal with remote colleagues? When the leader dies, what happens when the leader dies? When the leader itself fails, even if you have a single leader, you need to find a new leader, right? And then confused leader, when it becomes malicious. So which consistency models? You can pick any of those guys, basically. Fail stop, there are 2 kinds. Typically, we think in terms of 2 types of failure. One is called fail stop, where fail stop essentially means the machine dies. The other one is called Byzantine failure, where it becomes malicious, right? So when you have fail stop failure, the failure that are fail stop, which essentially the machine actually dies. If you are looking at a deterministic consensus model in a distributed settings under synchronous models or even asynchronous, you can tolerate 2f plus 1. That means the number of failures you can tolerate has to satisfy that equation. By the way, this should be, 2f plus 1 is fine, greater than or equal to, that's fine. And each, the other one is Byzantine. Let me explain the Byzantine failure. A lot of people don't get this, okay? Assume 2 people are getting married. One is in New York, other person is in India, okay? And the priest, for instance, is in Europe. Can you imagine in the internet world we can do that, right? If you go to match.com, you can do that right now, for instance, right? So Dave, in internet age, which is called the internet bride or bridegroom. I don't know how you want to. Yeah, smart marriage, smart contract. So assume Dave the priest is malicious, because I'm not going there. Why is malicious? Let's not go there, right? And Alice and Bob wants to get married. The consensus, the way it works is, Dave is going to say, Alice, do you marry Bob? And Alice says yes. And Dave asks Bob, Bob, do you marry Alice? And Bob says, remember, Alice and Bob are also talking to each other. They're doing consensus. But Dave maybe is jealous of Bob, right? Maybe he wants to marry Alice. He says, one's commit and the other side abort. They both are confused. They don't know whether to get married or not get married. You need the 4th node. That's why you need 3f plus 1 rather than 2f plus 1 in this case. Remember, in the fail stop model, you had 2f plus 1. In the Byzantine failure model, you need 3f plus 1 for exactly. You need another 2 priests. If you want to get married in distributed fashion, you need 2 priests. And at least one of them is truthful, right? So never get married with 1 priest, because you will regret your marriage, right? I just mentioned to you, Bitcoin world consensus model is based on probabilistic. You can actually go read, you guys can go Google search that. Based on proof of work, solves crypto puzzles, eventual consistency. Fan out of blockchain can have double spending for the short duration. So based on what is eventual consistency in the Bitcoin world? Remember the chain that gets longer and longer? You get consistency only after 6 blocks. Until then, you never know you will get consistency or not. And that's why it's eventual consistency there. The longest chain becomes your truth, and eventually you will get a longest chain. And there is a proof that eventually you will get a longest chain in the Bitcoin world, right? But not in the immediate sense, okay?
May I ask a question? So the most recent 6 blocks, you're not sure about those, if I understand.
Typically, they say 6 blocks. With some people with computing power these days, maybe you may have to wait like 8 or 10. It gets harder and harder as you increase the number of blocks. There is an exponential number, right, that they need to. Remember, they have to solve this SHA-256 hash, right, to get that chain. So somebody with network partition and other things, you wait for 6 blocks typically. That's the recommended. And you remember, you also have to think in terms of how many transactions per second I'm actually doing, how long it takes for you to get 6 blocks, right, and things like that. There is, so consensus, Bitcoin, smart contracts are constraints or conditions on transactions that are committed on the block, as you pointed out, right, same definition. Smart contracts are also stored in the blockchain itself, right, with version control. GitHub uses version control, right? Smart contracts are Turing complete in many cases. At least in the Hyperledger Fabric case, it is Turing complete. Ethereum Solidity that they have, the smart contract where they base on Solidity language, which is JavaScript, is also Turing complete. The same contract is executed on all replicated node. Okay, so let's do a little bit of hype and reality in this case and talk about business cases. How much time I have? Half an hour. I need 45 minutes. Lucky I'll run fast. Okay, hype and reality is straightforward. So let's do this. You've probably heard of all of this. So Bitcoin fraud, US government sues over alleged Bitcoins, CDF. When you see this, I bet any common people or common man, woman, anybody else are going to get scared of Bitcoins. They think Bitcoin is all fraud. That's essentially what this, right? And then we also have other things. Bitcoin saves the world. How can fraud save the world? Because now you can say, how distributed technology will make the world work better, right? Blockchain panic. China drops hammer on ICOs. You get regulators, banks, other things, right? We should make AI and blockchain be the global traders. Now imagine I have Bitcoin on the blockchain on one hand and AI on the other hand. They're going to take over the world. What do we humans do? We go to the beach, enjoy life, and all the other things that happen naturally for us. Unfortunately, we have to eat and we have to use our brain. Unfortunately, right? So this is a Satoshi's paper. If you guys are interested to go read, you should read. As I told, if it was submitted to POTSI, POTSI is one of the most famous distributed systems conference, Principles of Distributed Systems. I bet the program committee would have rejected. It's actually a very nice paper, but not very well written from an academic point of view. But it's probably one of the most revolutionary paper in a long time that I think, that personally I think. But you have to go read this paper, okay? And by the way, Satoshi Nakamoto, because sometimes I get confused with Nakatomi because there was a movie where Nakatomi was Nakamoto. Nobody knows who he is. I have my own theory, but I'm not going there, okay? Because it's being recorded, right? So blockchain beyond Bitcoin world. This is a nice Harvard journal, Harvard review. You should kind of look at it. So it solves intellectual property in digital world. Who owns the truth? Okay, it gives you a better mechanism for sharing economy, especially in countries where there are no banking systems, where you have microfinancing and places like that. Bitcoin can actually help, right? Opening up manufacturing from Internet of Things. These guys use the word ledger of everything, from Internet of Things to ledger of everything. This is something that I'm pushing, this idea of Internet of Things to ledger of everything in the TSS world. TSS technical support. We handle all kinds of parts, IoT parts and this like that, right? How do I create this ledger of everything? We always talk about Internet of Things, but we also need to think in terms of ledgers. Changing enterprise collaboration. How do I bring these? We are going to talk about that, changing enterprise. Okay. Okay, let's look some use cases. These are use cases that IBM works on very quickly, very briefly, right? So one of them is legitimize diamond and reduce fraud. What are we going to do? What is going on in this particular use case? These are some of them have been implemented, or actually all of them have been implemented. Track diamonds across the supply chain from mining to retail. How do I know the diamond I get is a diamond that you can trust and it has the value that has been suggested? Essentially, shared ledger for storing digital certification with supporting materials. There's a way to actually do that. I'm not a diamond guy. I don't wear any jewelries. I don't like wearing jewelries, so I don't know much about diamonds. It protects against occurrence of fraud, trafficking, black marketing, all of those things. It helps.
May I ask a question?
Okay.
Are you actually tracking the diamond or the box the diamond comes in?
In this case, they're actually tracking the diamond once it gets into because they essentially have a digital mark inside the diamond also.
Inside the
Yeah, they have a signature. Every diamond apparently has a signature. I'm not a diamond person, right? It's not just the box. No, it's not the QR code or what's the other one? A barcode, right? So Walmart food traceability, we'll talk about food, traceability in the case of mango, right? I'll take you through the journey. Traceability from farm to fork, it holds a history of processed food, and it has multiple parties involved in this, right? Who are all the parties? Now you may ask the same question, are we tracking the food or are we tracking the box? How can you track the food itself? Can anybody suggest? What can you do whether the food that you're eating is essentially, the history of it, other than the QR code on it? DNA, you can pick up the DNA of that food. That's unique for that particular thing, pretty much, right? Global finance, it reduces disputes. I'm not going to go into details. So IBM Global Finance provides like 41 billion channel phasing per year. There are a number of disputes that take place. So essentially disputes, think in terms of disputes, is I send money to you, you say you didn't send money to me. We look at the evidence that I actually send the money to you. What is it in crypto this is called? It's called non-repudiation, right? It's called non-repudiation in the crypto world, right? Show me the proof that I actually send the money. So there is a whole bunch of things that you can actually, not just one party at that point in time, you can essentially have non-repudiation kind of activities going on in the blockchain itself, right? The other one is MERS, which is cross-border supply. This is a huge project, which essentially, how do I know the containers that is crossing the border satisfies all of the border crossing regulation rules and all kinds of stuffs, right? So 90% of goods in global trade are carried by ocean shipping. Costs associated with the trading, documentation, processing, administrative, up to 1/5 of the actual physical transportation. IBM and Maersk are working to manage and track the paper records. Especially in India, I don't know, some of you may be true in some of the other countries. If I have to show a sheet of paper and give him money under the table too, to essentially cross the border, right? These guys are, some of those we can't really solve, but right? Food safety, I'm going to talk a little bit of food safety later. So these are some of the drivers: food fraud, food illness, traceability, freshness of food, all of these things you can essentially. So in the case of mango, I'll come back to this point, right? This is our current view today. We want to go into new world, basically. You can take a quick look at it. I'm kind of rolling up quickly because I still have a few more charts to cover. There are a lot of challenges here. You guys can quickly read it, from paper to logistics to regulators and consumptions and other things, okay? We want to provide end-to-end food traceability. So I'm going to skip all these because I'm going to come back to this. Okay, by the way, in the context of food, these are some of the people that are involved in the food safety blockchain partnership network that IBM is actually building, okay? Yes?
So all these applications are using blockchain, and why, like, how does IBM using blockchain to, what was being done before that it's done better now with blockchain?
So essentially the traceability of food from one end to the other end, like for example, tree to plate, right? And various parties get involved in tracking them and registering them so that we have, say for example, you consume a mango and you fell sick. You want to know where the hell this mango actually came from. So they can essentially track, and maybe somewhere they can look at the contamination, where exactly the contamination could have happened. Right now it takes like months to look at contamination. Especially in India, we don't even track for contamination. You eat poison food, you're dead. Okay, people cry and then they go on, right? Sorry, I'm recording. I'm being very insensitive here. Okay, let's do design thinking in 15 minutes, okay? How many of you heard of design thinking? Okay, you're going to learn design thinking. This is a 7-day workshop at IBM. I'm giving you in 15 minutes, okay? And I'm going to cram this. And the reason I'm bringing design thinking is actually important for building blockchain solutions. A lot of people don't know that, right? Why design thinking is going to help. But I'm going to take you, so tomorrow I'm going to take you through the actual use case of Mangost, right? Using design thinking, building blockchain, and showing how you can actually use the technology. So I have built a massive use case, which has gone all the way up the chain, right? So we tend to use design thinking a lot in IBM. I have been a facilitator for design thinking at IBM in a few cases. So I'm going to take you through this. So let's do. What is design thinking? Let's look at this cartoon. This should pretty much explain what the world will look like in the current world, right? So if we forget, what happens if we forget? By the way, this is from Jessica Ramirez somewhere. It's within IBM. I don't know if this was confidential or not, but I like this cartoon. I stole it from internal to IBM. I'm sure somebody's going to beat me up on this, but there's nothing confidential here. So hey, I have this awesome new technology for people to use. Great, I'll start building it right away. This thing is hard to use once you build it. I should get someone to make some better icon. You should add widget X so I can do task Y. Okay, if that will make you happy. This is how a lot of feature-based development looks like, right? So let's go. What does the end user say then? After you build this beautiful app in your iPhone, what will the end user say? Hey, I want feature function Z and widget W. I need this, okay, we can do that. You're a feature collector and you say, hey, I can actually do that. What is wrong in this? This guy, he has never done end user survey, right? Why is Apple so successful? It's because they know their end users. The other thing is there are really Apple, fans. Anything that comes out of Apple, they immediately go buy one of them, right? They think it'll be cool. And we say doomed, right? How can we keep up with all these changing requirements? So that's where design thinking comes into the mix. So design thinking is about thinking about your design that you're building from an end user's point of view. Don't build stuff that nobody's going to use it. In good old days, if you build something, somebody will use it. Those days are over, especially with the internet, with the iPhone and all the, the millennials. You guys, some of you are millennials. I'm an old goat here, right? Some of you millennials, you want something new, right? So design is an intent behind an outcome. Human-centered outcome requires empathy for people you serve. Solves complex problem, requires us to work together across the differences, okay? Design thinking has three major parts. There's a concept of principles, loops, and keys. So principles gives you a frame to see problems and solutions from a new point of view. What are the principles? We'll go through some of them. A loop is a behavioral model to understand user needs and deliver outcome continuously. You just don't do one-time thing, right? You go build an application, you're done, right? It needs to be a continuous thing. You have to think about that. Keys, techniques to scale your practice to complex problems and complexity. So the principles, essentially one is it focuses on user outcomes. At the end of the day, user makes sense. Drive business by helping user to achieve their goals. When you build your application, focus on the user and how that user is going to use. And also how is that user going to benefit from it, and if there is a value to that user. If there is a value, that user will pay money to you, right? Restless in reinvention, continuously reinventing. Apple has been very restless reinvention, right, for a long time. Diverse, empowered team, move faster by empowering diverse team to act. Okay, the third one is the loop. What you do is you observe, immerse yourself in the real world, reflect, come together and look within. And third, make and give some concrete abstract ideas. I know all these are abstract concepts, and I'll take you through this journey of blockchain very quickly. What are the three things? I'm going to mostly focus on these things. How do I align myself? The hills align teams on meaningful user outcome. You go do a user survey, 100 users. Among them, you pick the one that is the most useful for the largest subset of those users, right? And that's essentially what the hill will be. Playback is stay aligned by regularly. You can't have one-time interaction with the user. You have to go back to that user and say, hey, what do you think? Hey, what do you think, right? And sponsored user. Many times users needs to sponsor that. What does that mean? They put something on the table too. That means they get involved in this building of this, okay? So let's look at a hill. What is an anatomy of a hill? To write a hill, start with the user who you want to serve, basically. So there are three elements. One is called the who the user is. What do you want to build? And the third one is called the wow. How do you wow that user? right? So let's look at an example. Let's look at the top example, right? A GMU-based sales leader can assemble an agile response team in under 24 hours without management involvement. So if you look at who is the user, this is GMU-based sales leader. What can he do? Assemble an agile response team within 24 hours. That's the wow factor. There is a metric that you have to define for everything that you do. If you don't have the metric, you really are not going into this continuous user involvement, right? So you may start with maybe 24 months, reduce that to 24 weeks, to 24 days, to 24 hours. But still, that metric needs to come together. The second one example is it should take no more than 30 minutes for a developer to build and run an app using IBM and third-party APIs, right? So you could pretty much, so the last one, this is John F. Kennedy, right? I believe this nation should commit itself to achieving the goal of landing a man on the moon and returning him safely to Earth, right? That's the most famous statement that you can see. So for you to do that, user-centric development, you have to create a notion of persona. Persona is a representative of the community of users. That person, it's an imaginary person, okay? And that person may be even real. For instance, you can go talk to the sales executive for a particular client, and he would probably understand all the requirements of those clients. So that's essentially is the user, okay? Given a user, you build what is called an empathy map. What does currently that particular user, remember you're building something new. You're not building an existing system, you're building something new. So from that point of view, you can think in terms of what that user thinks, feels, does, and says. Okay, we'll go through this exercise tomorrow. You guys are going to do that exercise with me here, okay? And then there is something called scenario map. Scenario map is if I'm the user and I'm building an app for that particular user, that user is going to think in terms of steps of things that can help that user make his or her life better. So for instance, if you are building a billing payment system, what are the steps that the user goes through in terms of billing payment system, right? Those are the steps. You have what is called as is and to be, but the steps of as is and to be could be different. Many times they will be the same. But at each point, you want to think in terms of what is the person is doing, thinking, and essentially feeling too, okay? And then there is a concept of ideation. What does ideation mean? So when you do design thinking, you're bringing a bunch of guys. It's not a person with one person, right? Everybody have their own opinion. Design thinking is not just about design, it's also about collaboration, right? We bring all these people together to come up with what is the idea, greatest idea I can make that persona feel better, right, as we move forward. So the exercise of ideation is everybody has an voting rights, and you will see that in the next slide. You essentially take to color and focus in terms of importance and feasibility, and then come up with this chart, which is essentially called the ideation, the priority chart. So on one end, you have, it's feasibility, on the other hand, you have the importance. And then you essentially look at this, whether it's an obvious choice or whether it's a big bet or it's tough, and which way do you want to actually focus. If you're doing research, you want to go in this space, right? If it is no-brainer, you can get it done in 2 days. You can go finish it. You don't need big stuff. So that essentially gives you this prioritization, ideation, and mapping them into this importance and feasibility. Important tells you what's the value of it. Feasibility tells you what are the costs for doing it, right? So I'm going to stop here. I think am I on time? Perfect.
You have 10 minutes.
Okay, I'll take some questions, and I'm going to explain this homework for the last 10 minutes. There is a cheat sheet going around, okay? Think through this and come up with your own notion of personas. I'm not asking you to do, I'm asking you to think through that. So tomorrow when we convene, I can take you through the architecture of the Hyperledger fabric and the design thinking. We will go through the full exercise of doing this and see how we can actually build a partnership network for Mango Party, okay? So this is where I want to stop. I want to see if there's any questions from anyone. Let me ask you this question. Is this a good speed at which we are going? Does this make sense? Any feedback from you guys? Because you are my users. I need feedback. Any comments? It's recorded too, so I'll have to commit to it. It's recorded on a blockchain, by the way. Okay, any feedback?
Well,
Okay.
it was wonderful for me.
Okay, thank
It
you.
was a little fast, but
Yes, I've been telling Stan that I may come and offer a course on blockchain.
Yeah,
That is
I
what-
mean, we apologize for the speed. Fitting it, fitting it into our quote club hours when we have an hour and a half to probably cover a 3-hour lecture made today's challenging. Tomorrow there's 3 hours. There's much more time to be able to go through this. And this isn't the end. Sreedhar has talked about coming back and actually doing a much more hands-on workshop. So I think the idea is to get you interested and knowledgeable about enough to kind of see if this interest perks what you want to pursue this further.
I would be delighted if we do it.
That'll be fantastic. I'll be happy to do that. Yes.
You make your PowerPoint available to us.
I gave it to
Yeah.
Stan. He's my point of contact.
Yes.
Anything you want from me, ask him. He'll ask me.
Thank you.
Okay? And I will also send you information about the talk at IBM. People want to
Sure.
show up. It's not IBM confidential. The previous talk had some IBM confidential. This one, I'm making sure it's not IBM confidential.
Is it in the morning or in the afternoon?
I don't know. Sorry. I suspect it's in the afternoon. I suspect it's around 1 o'clock. I have to check.
You take Metro North up to Yorktown.
You can go up to Croton Harmon, and then you may have to get a taxi from there, basically.
Is there an IBM audiovisual system that we can watch it somewhere?
There is a recording of it. I don't know whether it gets exposed outside. I don't think so, as far as I know. Okay? But if you're willing to come, I can come and give the same talk here. I mean, if you invite me,
Oh,
I can come and give the same talk here but that'll be much more fundamental. There'll be some math in it. It'll be a little bit more deeper than what I just showed, right? It's more of people to think on the difference between Bitcoin world, which is permissionless and permissioned, from a much more fundamental concepts point of view.
Thursday afternoons, are you available?
Can we work out through Stan? So that's easy for me because if I say something, I do a lot of client engagement. Thank God I had other talks. I had to cancel it because at the end of the day, I cater to my clients. If they call me, come back here, I have to go there, right? So, but this one turned out to be very good. This took us 6 weeks to set this up. And we have been working through, Stan has been my very good partner in this. Okay, I'm done. Thank you very much, and thanks. I appreciate.
Before you go, let me just thank a few people. For one, Bruce Mead, who directs the IBM group in New York and the kind of the coastal area in the Northeast around advocacy. It was through Bruce that we made this connection in the first place. And then there are a few other IBM people who are here.
There's one, Len,
Who
and
both are support and who actually have been involved.
why don't you come in the front? You can be on the video too.
This has been a much larger partnership than just this. It's a beginning series around blockchain. For the last 3 years, we've been running a competition with IBM called the CUNY IBM Watson Case Competition, where students in the City University can come up with an idea on how to improve something the City of New York is doing or something CUNY is doing, and figure out how Watson technology can be applied to that. In fact, this last year, they actually built a prototype that was something the New York City Department of Health was interested in looking at and see if it could work. So from our point of view, Baruch is very, very mindful about the fact that the 21st century job requirements are really quite radically different from what most of us experience growing up. And so we are thinking about ways, and this is one of the important partnerships that we're doing in order to begin to bring our education into the 21st century. People have different job requirements, different skill requirements, and that places a different set of challenges on us as an institution of higher education. And this partnership is one of the ways we're doing to try to improve what we do. So thank you, and we'll see some of you tomorrow.
Thank you.
Can we also say,
Yeah, so as another part of the collaboration between us is that Baruch is organizing a CUNY hackathon in the Navy Yard on November 10 to 12. So whatever you learn here, you can win some prizes there. So I'd recommend it.
That's great.
I want to mention one last thing. This is also part of our effort from IBM Academy of Technology. I'm a member of IBM Academy of Technology to essentially work with the local universities and communities to kind of dissipate knowledge, right? And as part of our volunteer work that we do.
Can I do a plug on
Sure.
an internship program? So, so the Open Mainframe Project is a consortium of different companies. IBM is one of the partners for the Open Mainframe Project. And every November, so it's coming up, they accept applications for summer internships. It's a pretty competitive program, but I worked with one of the Open Mainframe Project interns this past summer on a blockchain project where he built a blockchain application using the Hyperledger Fabric. And it was a wonderful experience for him, wonderful for us. We got to know a student really well. I'm still keeping in touch with him. So if you guys want to apply, maybe I'll send you
Absolutely.
the information and
we'll circulate
encourage you guys to apply.
That's great. Thank you.
And I can be the advisor of one of the students, if you guys like me.
You do very much. Thank you.
Thank you.